Hi, I'm Scott. I'm a product manager at Pivotal, and this is Steven, another product manager / engineer at Pivotal. And we focus on build products specifically, and today we're here to talk to you about a concept we're calling Buildpacks Anywhere. A little housekeeping before. Some of the ideas we're sharing in here are pre-release, so they are subject to change. All right, so let's get started. So when you're a developer, as most people know here, when you're working on your code, you're working iteratively, and you continue to iterate on it before you get to the point where you're ready to push it to the cloud or some platform for production. And right now, there are a lot of options in our ecosystem to get your code to production. But here, this talks about why build packs and the build opinions that we provide with build packs are one of the best options for you. So with build packs, we like to focus on a specific value prop here. Build packs provide operational sustainability with increased developer productivity in the cloud. And we want to focus on two key aspects of that: operational sustainability and increased developer productivity. So when you click into increased developer productivity, what does that really mean? The biggest part of it is it allows the developer to focus only on the code and realize the value of that code and provide that to the end customer. So instead of focusing on the overhead of dependency management and security patching and production operation, they focus on providing value to the customer via pushing their application. And additionally, build packs provide a consistent development experience across for your developer ecosystem inside of your organization. So you get a consistent developer experience across new apps, across existing apps. So when developers start up working on a new project, they know what to expect. And when they push an application to production, they know what to expect. And that really scales from hundreds of developers to thousands inside an organization. And when you look at this from the other side, on the operational sustainability side, really what you provide here is developer productivity with operator guardrails in place. So you get developers pushing better code faster and more frequently, but there's operational guardrails in place to help make sure that it scales in production, it's being patched, it's working, and it's being developed in the right way. And dependencies are being updated, et cetera. And then also, we look at build packs provide scalable security vulnerability management. So what you can get is when your application is in production, if a high CVE comes out, build packs provide the ability to update your application automatically without having to go back to a developer to fix that and push it up through a pipeline. So really get scale and productivity. So we really tightly coupled this experience into Pivotal Application Service, which is great because you have day 2 operational scale with improved developer efficiency via CF push all the way to PAS. So this is a really good experience for this platform. However, as organizations and Pivotal start to look at other platforms like PKS and PFS and the kind of the Kubernetes ecosystem, you still see that build packs are tightly coupled to PAS. So you don't get to realize some of the value prop on these other platforms. And you're mainly relegated to something like a Dockerfile and a Docker image, which work for some organizations, but those don't scale as well to large organizations when you have kind of Snowflake Dockerfile setups that need to be updated when a security vulnerability comes up in production. And it's very hard to do when you have thousands of those. So given this state of the current ecosystem, we went out and we've been talking with customers on what they want to see from build packs. So here are kind of like the main takeaways that we've been hearing for all the people we've talked to. They want build packs in their local development environment. They want to use build packs on all their workloads. And they want the same security patching that they get from build packs, but for Docker images. They want faster builds. And they want a better experience when they promote an app between environments. So really this has led us to really rethink what our value prop should be for build packs. And now what we want to focus on is for build packs to provide operational sustainability with increased developer productivity for every workload in the cloud. So given this new value prop, really we are going in a new direction here for build packs and introducing 2 new projects that we're focusing on called Cloud Native Build Packs, which you may have seen introduced by Steven this morning at the keynote, and what we're calling the Pivotal Build Service. So this takes some key components of the build pack value prop and the build pack and staging process from PAS and expands them out to more workloads in different platforms, specifically things like Kubernetes, PKS, and PFS, and makes them accessible across for every workload. So if we look what that means for cloud native build packs, you're really increasing developer productivity for every workload. So the first thing that you get with these new cloud native build packs is exponentially faster builds. We've redesigned kind of the underlying architecture of these build packs that makes more efficient or provides more efficient caching and a better, faster build process. So you can also have faster builds in the clouds, but now you can use these build packs in your local development environment. So you can shorten the feedback loop for developing your application in your local development experience and not have to rely on pushing that application with the build pack to the cloud to get that feedback loop. So now you get much quicker development cycles with faster builds and your local, in a local development tool. And additionally, these produce an OCI image instead of a proprietary format like a droplet. Now you can use these OCI images on any compatible platform, which Kubernetes is one of them. So this not only gives you faster builds and quicker feedback loops, but gives you a lot more portability in your application artifact. So now if you go back and look at the diagram they have from before, and you have our different platforms, now with cloud native build packs and what we're calling the pivotal build service, you get a consolidated build experience in your platform ecosystem across all workloads. So now you get operational sustainability for every workload in the cloud. So this gives you a standalone build service that connects with your existing CI/CD pipelines and full operational control for all your artifacts produced by the build service. So now you can promote your artifacts throughout your CI/CD pipelines into consistent experience from platform to platform, depending on how your CI/CD pipelines are set up. And additionally, you get automated security patching for all container images in production. So now you can get that day 2 operational model for every container that you have in production versus just it being relegated to PAS. So now I'm going to hand it off to Stephen to provide a little bit more context on what this looks like in a real world use case for cloud native build packs and pivotal build service.
Thanks. So I'm going to tell you a little bit of a story about a particular CVE from 2016 in OpenSSL. This CVE it's a high severity CVE. It would lead to a denial of service attack in certain circumstances. So if you look at a Node.js app that's vulnerable to this CVE, where you have a vulnerability in OpenSSL, a Node.js app built using a Dockerfile would sort of consist of a series of linked images, where the bottom image is usually an image provided by an operating system vendor like Canonical for Ubuntu. You might have an image provided by, say, the Node.js folks that has Node.js in it, and then you might put your application image on top of it. So if you have 500 Node.js apps, when that CVE hits, you have a lot of apps to patch. You have 500 apps, and it's September 26, 2016, and what are you going to do? So if you do Dockerfiles and you don't have much management of these Dockerfiles, you end up with every developer's push something. Their base images are maybe all different. You have different versions of Node everywhere. And you really don't have a clear time to mitigation for the CVE. You tell your developers, hey, go fix this, and you hope that eventually everything gets fixed. It could take months, could take years, might never get fixed, right? If you do Dockerfiles right, and you carefully manage this, you have CI pipelines set up that create your one blessed version of Node for your organization, and tell your developers to build apps just on top of that thing, and you're really on top of it about building new images when updates come out. Then maybe you could get it to a point where you have to rebuild all these apps every time a CVE comes out, but at least there's some bounds there, right? So in Cloud Foundry, we have a kind of different model for this. We build a thing called a droplet that contains just the application and the application dependencies that's separate from the operating system packages. And we use the ABI compatibility guarantee, which is a thing I'll talk about in a second, to guarantee that we can swap out those OS packages underneath the droplet without rebuilding it. And this lets us patch a CVE for lots of apps simultaneously. I'll talk about that in a second. So when that OpenSSL CVE hits, Yes, just to talk about application binary interface a little bit. The idea there is that operating system vendors provide this guarantee that when they patch, for instance, Ubuntu 18.04, which is what our root file system in Cloud Foundry is based on, when operating system vendors patch those packages, they only fix security vulnerabilities, and they really make as good a guarantee as they can that they don't break compatibility with existing application behavior that's built on top of them. So in PAS or in Cloud Foundry, we have a really efficient model for updating this sort of application base layer, this rootfs. And we do that, we kind of use the structure of Cloud Foundry where we have these Diego cells that are running individual applications, or a cell might be running 100 applications on it. And we, in order to patch that application operating system layer, we start new cells. For sort of one at a time. We start a new cell, and we take down the old cell, and we start a new cell, and we take down the old cell, where the new cells contain an updated set of operating system packages, and the old cells that contain the outdated set eventually, those VMs get stopped. And so the time to mitigation when we do this in Cloud Foundry is usually just a few hours to roll all the cells in your platform. And so this lets you patch a high CV in OpenSSL in just a few hours with really guaranteed bounds. It's a really sort of powerful model for updating, for doing security updates. So when we talk about build service, this sort of new idea we have for a product that uses cloud-native build packs, this sort of new idea we have for a build pack API that'll be sort of unified across build pack ecosystems. We start with the Cloud Foundry model, which is a droplet on top of the operating system packages. But we expand that out into layers that live in an OCI image registry. So your app has its own repository, but instead of having a copy of Node.js for every single application, it can just point to the Node.js on the registry. Instead of having a copy of those operating system packages, lying around different places, we just point the app repository, just the image configuration at the operating system packages in a particular repository that stores them. And this uses a new feature of Docker registries called cross-repository blob mounting. That's a sort of a very recent feature in Docker registries that lets us do this, where we can point images at each other without kind of duplicating things. We can just say, this layer goes there, this layer goes there. So when we want to do a patch, we just upload, so for the vulnerable operating system packages, we just upload the new ones with the patch and point all the images that are out of date at the new ones. And so the time to mitigation there is really fast, because we can just make a metadata change on top of the registry, and then all you have to do is get your new images out to the place where you want them to run, and that's it. And the layers that will get copied to the edge nodes are just the updated layers. There's no duplication. It's really efficient in terms of data transfer for every leg of the way. So the idea for Pivotal Build Service is this idea for a new product is that we can intelligently and rapidly update app images according to operator rules and developer preferences. And that's what we got. Any questions? Right over there. Just wait for the microphone.
So with the Java build pack, will this work the same way? And also, how granular are the layers? Like, will, for example, like Tomcat version be like a separate layer that you can update if there is a vulnerability in Tomcat?
Yeah, there's a lot of work going on right now around that. You should talk to, there's a sort of a separate team that does the Java build pack, and they're looking into this, and they actually have some stuff already that's really cool. I think they're planning to be fairly granular with how they make those layers. I'm not sure where they're at quite, right now. And I don't see if, I think Ben Hale's in the background there. Sorry? All right, we can talk after with Ben Hale. Any more questions? Right back there.
So I'm thinking of PAS in particular and the apparent need for a registry now.
Sorry, can you speak up?
Yeah, I'm thinking of PAS in particular here. So it seems like a registry will kind of be a required thing now. Will it be kind of like an S3 blob store where there's an internal option, but really you need to use something else? Or what do you expect things to look like with PCF going forward?
I think you're asking, what does PAS look like in this new world?
Yeah, kind of
Yeah.
a new component, it seems, so.
Yeah, that makes sense. So I think there'll be a sort of a careful migration into something that looks like this. This is a really new idea. We haven't quite worked out everything yet, but you could imagine that this would be powered by a Docker registry, and that ideally it wouldn't need another blob store besides that we can use the Docker registry to do the storage. But we're not quite sure how this ends up integrated into PAS quite yet, if that makes sense.
Yeah, thank you.
Yeah. Up here in front.
Would you still be using like a Dockerfile to build these images out to then be fed to the builder?
I guess which images?
The new images that are curated?
Yeah, so I think app developers who are using these build packs wouldn't need a Docker file, right? The build pack would take care of that. If you're, creating a new rootfs, a new stack with operating system packages, that might be a place where you could use a Docker file or a number of other options for building up images if you wanted to. I think no part of this requires a Docker file. It's not in the API spec or anything like that. But you could use Docker files in different places if you want to. It's all open standards. It's all in OCI format. So it's much more extensible than stuff we've had before.
So, but if you did want to, like, let's say you use these new images as your base image that has the build pack and build on top of it, you could do that?
Yes, I think there are different images in different places you
Okay.
could update, but
Sure.
in general, yes, you would be able to do that, if
Okay.
that makes sense.
Sure.
We can talk more after if you have more specific questions. Over there.
So for local development, what does this look like? Like you're kind of standardizing how you deploy to the platform, or multiple different platforms, but how could this impact me if I'm doing local development?
Sorry, if you're doing what kind of development?
Local, like if I wanted to run everything locally?
Yeah, so we have a CLI right now called Pack. Emily is working on that right now, the person who just handed you the microphone. That'll let you do all this locally against a Docker daemon, against a local registry, against Docker Hub, whatever you want. It all works. We have a lot of different options there. You can try it right now. We even have some sample build packs that work on V3, and we're working to get the Cloud Foundry build packs converted too. Actually, the API even has a special section just for an improved developer experience on top of build packs, where build packs can supply sort of development dependencies and things like that too. So we're really, really heavily investing in that area too.
I want to add on to his question about the Dockerfile, because it seems that as Kubernetes becomes more standard throughout the industry, that a lot of security packages are doing a lot because they're, and Docker is inherently not secure unless you do a lot of things with it, including making sure you scan and register all the software that's being installed into your container. So I'm concerned that if it bypasses a Docker file, that may eliminate some of the security practices. So that's the first of two parts. Go ahead.
Yeah, so a lot of those tools, as a matter of fact, all of those tools I'm aware of just scan Docker images. They don't care about Docker files, right? A Docker file just says run this command, run this command, run this command, and it generates some layers. The thing this outputs in the end are OCI images, which are the same thing as Docker v2 image format. It's all the same. So you get all the security tools you have that'll work to scan Docker images, should work to scan the images this spits out, and this can keep those images up to date automatically on top of that. And part of this API is we now write a bill of materials into the metadata for each image, so you can see exactly what's there and script against that if you want to. So actually, we think this will be even better than just using those tools on top of it.
Okay, excellent. The other question I had then was, do you know of any clients using this in production?
They're using this build service we're talking about. This is an idea right now. It's not a pivotal product yet. That's kind of why we had the disclaimer at the beginning. This is something that we have started building some tools for already, and there's a CLI you can use. We actually have a project that's going to enter the CNCF next week called Cloud Native Buildpacks that introduces this specification and tooling. But this is just what we're doing on the pivotal side, what we may be doing in the next year or so, if that makes sense.
So where does this fit in with multi-build pack support, or if at all? So
Yeah, so multi-build pack support in Cloud Foundry was introduced, I think, probably around 6 months ago. The idea there was some contract changes that would let you use multiple build packs together. This takes all those, takes a very similar model. It sort of takes from what we learned from doing that and extends it even further. So now there's multi-build pack support, but we also have multi-detection. You can do detection with groups of build packs instead of just detection with one build pack. And it lets build packs even granularly break up the layers they're going to write to keep them up to date. So it's an extension of that. It goes even further. It makes it even easier to write modular build packs that contribute into a build. Hopefully it makes it sort of a more standard process too than the kind of model Cloud Foundry uses right now, which is very Cloud Foundry specific. If that makes sense. Over here? I think the hand in the back has been up a few times. If that's okay.
So I understand this is a future thing, but let's say we've got customers that looked at PKS and they said, oh, this is exactly what I want. I have to, I want to transform a bunch of workloads. Do you foresee the build service becoming part of the PKS application or just part of the foundation? What's your thoughts there?
Yeah, I think we're not in early stage, so we're not ready to quite say what our what platforms we would encourage people to use this with, but it builds OCI images and those will run fine on PKS. That's definitely an option we're looking at. Same with PFS as a function service. You got to build your function somehow, right? So definitely we're looking heavily at both those things, but we don't want to quite say yet what we're not ready to quite say yet what we want to do there, if that makes sense.
Okay.
Well, I was going to ask then, so what do you see then as the future of PAS?
Yeah, so we plan on integrating this into PAS. So that's the goal for this. It's a major goal for this is to give PAS the best possible build experience. I think we'll have tight integration in PAS for sort of making sure the build's there as fast as possible, and then it's an awesome experience, if that makes sense. But we may also look at PKS and PFS too.
Another question is, as the image is switching underneath, does it require any restarts of that image, that container running?
Yeah, so the process of rebasing those images it doesn't require any data transfer, right? It's just it requires a negligible amount of data transfer. It's just a metadata update on the images, but it does generate a new image ID, which is a good thing for security because then you can decide, oh, actually, I want this to go through a pipeline because it's a really important app, or I want this to get deployed right away because it's a really bad vulnerability, right? You can make intelligent decisions based on the vulnerability there, but it does generate a new image shot. So you do have to have a platform that knows how to deploy that, right? But we see lots of different opinions in that space, right? People like to use Concourse, people like to use Spinnaker, people like to do all sorts of interesting things. And so we kind of want to leave that more to those opinions to how these images end up getting deployed, if that makes sense.
Sure thing. Cool.
Any more questions? All right. Thank you.